Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics.
Welcome to Speaking of Reliability. This is Kirk Gray.
And this is Fred Schrenkberg. Hey, Kirk.
Hey, Fred. Good to hear your voice.
Yeah, it's been a little while, but Carl asked an interesting question. But before I get into that and we dive into today's topic, we were chatting offline briefly about site reliability engineering. It's basically the software to keep a website up and running, and it branches out into databases and a bunch of other stuff too.
I'm sure it could involve hardware sometimes, maybe.
I'm sure it does. But the idea is that it's like this other branch of reliability engineering, and they're often advertising for reliability engineers or senior reliability engineers, and it's a job that's more very much software centric and website centric. And why I wanted to mention is that if anybody that's listening to this knows anybody that has good information or has written a bunch about it or would be willing to share their content through Ascendo, it might be a nice addition so that we have an idea what this other fraction of reliability engineering is all about. And it's a big market too. So I think it might be a nice way to increase the ability of Ascendo to meet that audience's need. So if you know of any of that, just let us know.
You've got about every other corner of reliability engineering covered, Brad. So
yeah, except for that one.
Right. And I don't see a lot written about it other than, just
well,
briefly.
There is. I reached out years ago to the guy at Google that wrote the book called Site Reliability Engineering, and I didn't hear anything back. So I was like, all right, whatever. They're busy doing their job. But if anybody knows somebody or somebody else or a podcast or whatever, something that we can get some content out there on a regular basis to help people in site reliability engineering, but also just in general, because I think that today's topic on the future of HALT, and we were chatting just briefly about it, is that can you do HALT on software on a website? It's not the traditional vibration table, but maybe it is. I don't know. But Carl brought up this question the other day, that he's trying to write an article about what's the future of FMEA, and given current trends, where's this going? How's it going to evolve and stuff like that? So that's a question for you,
right,
Kirk, is what's the future of HALT, HALT?
Well, each talk about our specialties in the future of
That's
it.
Right. I'll ask Chris to talk about Weibull analysis.
Exactly. Anyway, yes, I think future of HALT is that it's becoming much more recognized as a very comprehensive and useful tool. And right now, people think of terms of simple vibration, thermal step stress, and then maybe the combined environment of vibration and thermal cycling or together or something like that. But there's so many other opportunities with voltage, frequency. You can make a matrix, power, transition,
power on and off cycles.
Right. Transients and things like that. And I think really useful role in this in being able to interpret signatures of like the clock speed and low temperature or something like that, and voltage together, so that they have this three inputs and vary those. I also think that that'll be possibly we'll be able to transfer these into models too, and we can better diagnose marginal boards. Like if we do a random audit, we can be much more high resolution of the performance of a circuit board or the performance of a system under stress. not under its use environment, but under the boundaries or close to the limits. And that's where the variations really show the most is under stress conditions. You don't see a lot of variation in the operation when everything's at ambient conditions, very normal, uh,
Unless
simple.
your unless your
Less,
process is pretty bad or your design's pretty bad, then you'll see plenty of variation. But you're right. Yeah, most of the time they're good. But a lot of the diagnostic equipment and software systems we run and onboard diagnostics and so on, that
right.
all pretty, I mean, if you're looking at clock speed, those tools already exist. It's just that you don't see it very often on a board is what we monitor. Usually it's just, oh, the green light's on, so it's still working.
Right. People don't, it takes more time to
Set up
set out, right,
and
and
measure
do
what
the
you want to
variation,
measure.
do the many different iterations. But I think as we automate this, or we get more oriented to monitoring parametrics of this circuit and have better tools using AI, that they can compare much more data together in much more of the signatures of performance at the four corners, and then adding other stresses besides temperature and processor speed or bus
Yeah,
speed,
the
voltage.
folks that created Halt chambers kind of did Halt a disservice. It was, vibration and temperature controls are
Right,
common stresses
right,
for electronics,
right. And they do
right?
create fatigue damage, which is rapid aging
Right.
of circuits, of mechanicals.
Just because you make a chamber and yeah, it costs you $1 million or whatever they cost these days, doesn't mean that's all you need. That's not the end of the day here. Various scopes and various probes and various monitoring systems and
Right.
all that
Logging.
stuff
Yeah.
still counts and changing the voltage that's being applied or the power is being applied.
Right.
It's those you still got to think about it. Just because you bought a chamber doesn't mean you're a Halt expert. I
No,
think
and you
the
don't
people
necessarily,
selling them, the people that sell them
quote,
don't
halt chamber.
they should
Right.
be they should be selling the full array of all these diagnostics for different technologies, not just the chamber, but they don't.
Well, yes, but that's kind of hard to do because the oil well, instrument
It's
companies.
completely different than an automobile
Yeah,
or
right,
the
right,
cell
right,
phone. Yeah,
right,
I
right.
get that.
So
But maybe that's a business opportunity for the future of Halt is we sell all the good stuff and they sell the chambers.
I don't. I think that it's just like halt. You always tailor it to your product and tailor it to,
What you
what you
know and don't
know
know.
about
Yeah.
what you already know about the product. You don't go test things that have shown excellent reliability in the field over 2 decades.
Yeah, it's
That's
kind of a
just
waste of time at that point. But it's what trends are you seeing? There's AI stuff, but I don't I mean maybe for the diagnostic part and detecting anomalies, but it's what other trends are at? Because you mentioned when we're off air is that your book's selling a little bit more.
right.
Is that a good sign?
I hope it's gotten more acceptance. I don't see. I'm not aware of anybody writing another. That's 10 years old now. See, yeah. Well, next year it'll be.
Well, it's
It
time for
pay,
second edition.
but I not being real active right now. I don't have a lot of new information. Again, the problem with the whole reliability engineering, nobody has a lot of time to publish, nor are they allowed to publish because they
Yeah, there's a
can't
combination
talk
of those.
about
Yeah.
right. Yeah, two things that keep the information really locked into most companies. So uh, I think that it's still talked about at conferences. I just saw some a recent article. I looked at reliability engineering in Google News that somebody brings up that one of his prime tools is halt. Yeah, it's gotten more kind of a better acceptance, I believe, over time, but it's just a matter of people willing, and once they try it and use it properly and uh, understand what their goal is to find limits, not necessarily to simulate the environment that it's going to be in.
Well, do you think the name's ever going to evolve to
It
limit
is.
testing, or
It
because there
is.
used to be, what was the variations of HALT before Greg really kind of centralized the name? It was MOEST, I've heard people use.
Oh, that
Strife,
yeah,
HP had
that
Strife, handful of other
well,
companies
HP
had different
had
names.
no Strife was before Halt. Okay,
Yeah,
so that the idea of using high levels of stress is not new. ESS, environmental stress screening, is was a classic
been around
introduced,
for a long time. Yeah.
yeah, in the 70s by the Army. It was actually the NAVMAT that started to talk about that, and
Hmm.
so um,
So the primary stress or primary trend you're seeing is that it's getting more acceptance and people trying it. Yet the basic issue, and I don't know how that's going to evolve because it's really easy to do halt poorly. And with more pressure on time and smaller samples, and we need answers quicker, and doing it quick, faster, and cheaper, and less expensive is an ongoing forever type thing. And as you know, and we've talked about before, if you do halt well, it might take you 2 or 3 days on
right,
whatever system you got, but you put in the time prior to think it through and what are you going to measure and what are you going to monitor, what stresses to apply. If you do those things right, it takes you a week or 2 weeks to get all set up and running for a
right,
typical
yeah,
electronics box, like a
right,
computer, right? Using that as an example, you will be amazed at what kind of value you get out of it. But if you just
right,
throw a couple things in the chamber and shake them up a bit, and then everybody says, well, of course it failed, you overstressed it,
right,
it's a complete
right.
waste of time. And I
Right.
think that's the spectrum.
If you don't compare limits with, you go to limits for samples like 3 to 5, and
Hmm.
you don't compare those limits and say, well, this one operated to 70 degrees, and this one operated to 3 of them operated to 90, and this one only operated to 70. And there, you gives you something to look at. You can't say didn't find anything. You found a wide variation in the basic function of the unit under stress, which means there's some component in here that has a high effect on on its limits.
It's a response to that stress. Yeah.
And if you look at, just not a statistical distribution, but just the possibilities when this deviation is in a larger population of 1,000 or 1,000,000, that's going to represent,
Well, it's 25%. Yeah.
it's going to be a tale of the ones that don't work. Or
Yep.
this is anyway. That's the kind of thing that, and if they're motivated to do that, then it can carry them a lot. And I get these people to say, "Oh, we did halt, we didn't find anything," and I'm going,
Right.
"Well, you didn't do halt then, because you
Yeah.
found a limit. If you did halt, you would find that we had a limit at this time, this level, and when we compared it with our other samples, they all had within 5 degree limit, and it was well above 130 C for the motherboard. So and I say, well, then you probably have reached the fundamental limit of technology, and you're right. But now you have that huge margin
Margin that you know about. And
that you
now if you
can,
see something else, yeah, if you see
right,
something else going on, then you know that something's wrong.
and you have set a baseline for what you can expect for this kind of circuit board or this kind of system should be able to operate to generally.
Right.
Okay. And then also, it should be able to do this in the future in 1,000 units or 1,000,000 units produced in the future of its computers. It should be able to have the same margin or something, significantly changed. Also, I can use this margin now for any startup pilot program or pilot line manufacturing. Now that I know what these margins are, I can use that fully to decrease the time I need to put it in a stress chamber or do a HAS, where I do a combined stress environment with voltage and maybe clock speed, power cycling, lots of things that are not in the chamber, uh, plus the vibration thermal cycling to the maximum safe capability of the product that won't damage good product. Or
Yeah.
we've proven through our proof of screen or safety of screen that it's not going to damage good product. So it's just a whole different orientation. It's just
Yeah.
a
Well,
totally
another, I
different
mean, other
orientation.
than us talking about it here and your articles on it, your book on it, and I think Greg's book's still out there somewhere. And I think what's the other guy?
It would
Oh,
be Harry McLean,
Aaron
maybe.
McLean. I think he had a book out there at one point. They were
Yeah, I don't.
dueling and for whatever random reason. But the
Yeah,
idea is that where do people get trained on it? I don't see it in when I'm looking around at what goes on the reliability calendar for which training or seminars or workshops or conferences or anything else. I don't see anything on HALT in
no,
particular.
sadly, it's. I mean, obviously, I have 20 years of material that I've used, and over the time, and I could, maybe we could do one together again because I do think it's important. But that I've times that I've tried to sell it through what was a traditional halt uh, educator site, which is I don't believe is no longer teaching halt, really, in my
No.
opinion, and that's sad. But Greg Hobbs is long gone. He died in 2010, I think, and we there's nobody else to challenge the rebel that I was and I am and Greg was and Mike Silverman and others. I think, Adam Barrett is doing a good service to talking about HALT and
Hmm.
testing using stress testing, and he's very much a strong advocate of that. And I'm glad to see him post things about it. And that may be the one that's doing it. I don't know. He seems to be traveling awfully a lot on his
But there's not
motorcycle.
a, yeah, it's
Yeah,
not,
just finally, but
but it's mostly word of mouth that people hear about it or say, oh, we should try that, or they ran across, us talking about it or Adam talking about it, and
yeah, or
let's give
bought
it a
my
shot.
book or hopefully something like that. But it's really hard to do without somebody that's ready to defend this new approach and break things with all we know about what will be said.
Yeah.
Of course you
Yeah.
broke it, of
Yeah.
course it failed, that all that stuff, the barrage of, well, it was working on the bench fine, kind of
Right.
thing.
Yeah. Your
Yeah.
customer doesn't use it on a bench.
Right.
On your bench.
And customers don't usually have a sine wave, in it's like
It
the
stresses. Yeah.
ED, yeah, yeah. Anyway, so yeah, I think the future is AI can help digest more combined environment stress and information and analyze it and be able to look at more complex signatures than a human can with like voltage vibration or not vibration, but voltage, thermal, bus speed, um,
Well,
and
there's a problem there, Kirk. It's like, what are you going to train it on? The signal, this is a real signal of a problem versus this is just different than what else is going on. And if you combine 100 different measurements, you will find parallels and things that synchronize each other, opposite each other, just by random chance. And
right.
how are you going to tell which are which?
Well, you do comparative analysis. You look at and this maybe involve more than what your typical halt would be, 5 samples. You might, and depending on the product, 100 samples.
Wow, now you're getting into statistics. I knew I'd turn you into a
Well, there
statistician
you
eventually.
go. There you go.
There you
It will come down to that, and it'll be an AI generated statistical variations. It can look at the signatures and say this parameter is wildly off on these, five
go.
samples out of 95, or we see this trend. This one parametric is quite variable, and we can see where the variation in the component is, or we know which component, we can see which component is contributing to that, or the most significant contributor to that.
But anyway, yeah, I think there's AI coming. It may help with the diagnostics and the defect detection, but we see a waning of training and ability to learn about it, awareness and stuff like that. We don't have a over the top personality that's championing the process and making it work. There's chamber manufacturers that are great for some applications, but they're also not necessarily advertising and training people on the principles of HALT. So I
Right.
think the
Yeah.
future of HALT's kind of, well, I'm sure some people are going to say this is useful and valuable. We'll keep doing it. And others are saying, no, we don't know what that is and we're not going to try it. And I think it's a crossroads for HALT. That's my thought on it.
Well, I think those that have used it and have found benefit, hopefully it'll spread. I don't know. I'm watching the industry a little bit. I look at when I see an advertisement for a development, reliability or quality engineer, I kind of see if they are asking about HALT or HAS, and it's,
Mhm.
all the traditional FMEA, modeling, Weibull, things
Mhm.
like that, that I don't know. I'm sorry. I don't see those. I kind of see a lot of it as the elephant dance. We're keeping the elephants away because we're doing this dance.
Yeah, well, we don't need elephants in the lab. Yeah, yeah,
Yeah, and you see the elephants, so it must work.
must work. Yeah. Until you ship the product, then you see a bunch of elephants.
And I'm going, there's so many companies that don't do FMEA and HALT and all the other things and somehow end up having a reliable product.
And a higher proportion of those also don't have a reliable product. There's ones that, yeah, well, that's a whole nother topic.
Okay.
Another topic.
Okay. So I think that there's still opportunity to separate the wheat from the chaff in the whole field of reliability engineering and find out what's really valuable and what's really not.
And the things that are of value, I think are going to win out in the long term. There's a lot of headwind. We still do parts count predictions for no
Somebody
particular
does.
reason.
Yeah.
People make a living doing it. It's like, that's got to be banned. But anyway, if
Yep.
you're listening to this and have an opinion on HALT and where it's going and how it should be, maybe it'll evolve into the future. Maybe it'll get renamed. Maybe it's, keep it a wrap. That's your secret weapon for your production, your product development process. Let us know. Head over to accendoreliability.com/go/SOR. You can find a couple of ways to get in touch with us. And Kirk and I and the other hosts are available through LinkedIn and our about pages on Accendo. So plenty of ways to let us know what your thoughts are, and we look forward to hearing from you.
All right.
Thanks, Kirk. We'll talk to you again soon.
Talk to you soon, Fred.
Thanks. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.